Okay, so now that we've finished preparing the models, getting all the supports done, we're going to go ahead and slice our file here so we can print it. This is a plate or a platform I've already set up. I won't actually be printing the grunt that I showed supporting, which is the standing grunt, because I don't need any. I'm going to be printing the firing grunt and the sleeping grunt, which you can see over here. And I've also added some plasma rifles, which I will also include in the Thingiverse uploads, so you guys have access to that as well. But basically at this point my platform is ready. We can use the top-down view here to make sure that everything is spaced in the correct spot on the plate. It is a good idea when you're printing multiple items to keep the items spaced evenly. And what I mean by that is, for example, this is your x-axis here running across left to right. You want to keep the grunts on the top the same distance from the center as the grunts over here on the bottom, because if not, the peeling force on this platform will be uneven and it will try and tilt the platform while it's printing, which will ruin your print. So try and keep your objects spaced out evenly so that the peeling forces is evenly distributed, and that way it's pulling straight down on the plate. So okay, so you're just going to click the slice button up here, select the folder you want, and then it's going to pop up this little window here. And just make sure that your machine profile here and your resin is the same as the one you used over here in the actual file itself. And then down here, this shows you some interesting stats. It shows you the milliliters for each item and the supports and the amount of volume that you're using for the supports. So for example, on the plasma rifle right here, if we click on this one and you go over here, the support volume was 30% of the total volume. So in other words, the volume of resin it used to print the rifle, 30% of it was just supports, but that's because the rifles are so small. And then up here it tells you the total volume that you're going to need for the entire print is 40.5 milliliters. And then this tells you how much resin you're going to need roughly in your vat. But keep in mind that their vat is different than our vat, so we're not going to go off of this, but it's interesting to have this data here. At least we know how many milliliters we're going to use to print the objects. And from that, we can calculate cost if we were going to sell these. So you're basically just going to hit OK, start slicing right here. And it's going to start slicing like this. And one thing you can also adjust from here is you can adjust the resin profile that you're using, because the slicer settings are saved in there. So if you just click Edit here, this is a quicker route to get there instead of going through the menu up here in the program. But basically, when you pop this open, this is all of your settings that are going to be used when you hit slice. So I have mine set to, notice right here it says job export, it's images only. I'm not sure what the CWS file is. I think it's a Creation Workshop file because that's the extension Creation Workshop uses. But when I tried it as an export option, it didn't export a file that Creation Workshop recognized, so I'm not sure what that is. But all I want is images only. So I've set this to 8-bit PNG because technically these images are only black and white. We don't need 24 and 32-bit images because they're going to be much larger, and it's going to take a lot longer to slice this file if it's trying to generate 24-bit or 32-bit PNGs as opposed to 8-bit. So I'm just using 8-bit images only. This zip slice export just zips the folder when it's done. I don't have that on because I want to be able to go in there and look at stuff. This is for something we don't use, spatial mask, flip the slices. If you wanted to flip the X or the Y direction, you can use these buttons. Y is on by default. It just flips the direction of Y when it actually slices it. And then right here, we can also choose anti-aliasing. And I did have some problems with this when I printed, and I will mention them later in the video here. But the anti-aliasing essentially anti-aliases or smooths out the edges of your black and white image that you get on each slice. And while it does smooth out the shape of the borders on each slice, it also makes them smaller at the same time. So I did use the 2x for the print, but I would highly recommend use the 8x because it's much smoother. The 2x really doesn't do much. And keep in mind that since this does shrink the boundary by roughly 1 pixel all the way around, 1 to 2 pixels, you're going to need to bump up the size of your supports by roughly 0.1 to 0.2 millimeters, which is basically 100 to 200 microns larger. And that's going to compensate for the fact that the anti-aliasing is shrinking the footprint of the slice, because otherwise your supports are going to be weaker. So keep that in mind. Preview images, I don't have these on because I don't really have a need for a preview image. I would rather just have the full resolution image that's being sent to the printer anyway. The DLP options here are going to give you critical build angle settings, non-critical. This pixel dimming is to dim pixels. So let's say you had a really thick model that you couldn't hollow out or you didn't want to for some reason. You would want to enable this, and basically what this does is it says if the model's over a certain thickness, which you determine here, it makes the pixels a little bit dimmer so that the resin doesn't overheat, because the curing of the resin produces heat. So if you have a very thick part, it's going to produce a lot of heat, which also accelerates the cure, meaning that it doesn't need as much time. So by using this, you're essentially slowing down the cure ratio in thick portions so that it doesn't overcure the plastic and either cause a problem with the print or just stick to the vat really crazy. So we're not going to be using this because everything is hollowed out. This is other settings for table part distances, which we don't really care about this stuff. Down here is where you name the exe file and the name of the exe minus the extension. And when you check this off here, when it finishes slicing, it'll start this program, which the print controller is Photocentric's actual host controller to run the printer during the print. It doesn't happen from within Photocentric Studio. It's a separate piece of software. And for some reason, I don't know if it's a permission issue or what, but this program, while it does launch from within the software here like it should, it can't seem to connect to the printer. So I'm thinking there's some kind of permissions issue. Even though I'm running Photocentric Studio in admin mode, it can't connect to the printer correctly. But if you start it up as a standalone program, it works just fine. So just keep that in mind. G-code settings here. These are the settings for the layers as far as the amount of seconds per layer, the amount of seconds for the bottom layers, how many layers are on the bottom, which are basically cured longer so the part doesn't fall off the platform. So in SLA printing, you're always going to cure, or I should say most of the time you're going to cure the bottom layers more than the top. And that just, like I said, prevents the parts from falling off. And down here, these are settings we're not going to use. You would use these if you were exporting a complete file, but since we're exporting images only, it doesn't matter. This is G-code scripts where you can put custom scripting. We are going to use custom scripting, but we're not going to place it here because we don't need it. Remember, we're just exporting images. So if we're going to change something, you just hit save, and then you just hit slice, and it's going to start slicing. And I'm not going to actually let this complete because it takes a while, and I've already sliced it. So I'm going to go ahead and cancel this, and then I'll show you guys the actual host controller connected to the printer and the actual printing process. Okay, so all we have to do now that we've sliced our file is start up the print controller, and I just created a custom shortcut. The actual location of this file is in the Photocentric Studio folder, so if you just go to the install path of the program, you'll find this exe there. So we're just going to start this up. And I've used it before, so all of this is set up, but if you've used it previously, as soon as you plug these devices in our case the printer, it's going to show that it's already connected. You don't have to do anything here. So display 2 is the printer. COM3 is the USB port we're using for the printer. Make sure and change the baud rate here to 250,000 and make sure the data bits is set to 8, because if you don't have this set up this way and you're using the same board that I'm using, then it won't work. So make sure this is set. You're going to save it. And then you guys might have to hit refresh ports here to get your COM port to show up, but most of the newer computers refresh the ports pretty often, so it should show up anyway. So all we're going to do now is select Slice folder. Okay, and now that we've selected our folder, you can see it right here in the path. If we go down here and scroll up and down on the bar, we can see our layers. So that's our layer preview right there to show the actual outline. And one quick thing I did want to note is the slicer in Photocentric is slow compared to Creation Workshop. However, if Creation Workshop, if there's some little intersecting face or a hole in the mesh making it non-manifold, you will never get a successful slice file like this. It will end up with a bunch of lines and missing parts. So in other words, where the print should be white and solid, you'll end up with gaps, which will make your prints fail. But the photocentric slicer, however it operates, it must take into account the volume of the models in addition to the shells or the mesh. And however that works, it will slice files that are not manifold. And I'm not saying that it works every time, but in my experience, I have sliced multiple models that had manifold issues where there was a tiny hole somewhere that I could not find. And every time the slice was successful and the black and white image of the slices was perfect. There was no flaws. But I would open those same models in Creation Workshop and there would be multiple problems and gaps. So just keep that in mind. The slicer is very good quality. So now that we've got this showing, we're going to hit connect, which will connect it to the printer. And then you can see right here, it says machine connected. And we're going to go right here to manual controls. And if we type in a capital M and a 106, this is going to turn our backlight on, because right now the backlight should be off because it's controlled by a relay. And when we hit this button, it's going to turn the backlight on. And this will enable us to see the desktop, because obviously without the backlight on, the screen will be black. So if you look at the screen on the printer now, you should see your desktop background. If you just change this to a 7 and hit send again, that will turn your backlight back off. You don't want to leave it on, obviously. It's just going to generate a bunch of heat. So this is all automatic in the G-code script that we're going to use. So right here is your current layer. This grid right here just makes sure that your screen is working and that there's no distortion or anything, or it's not uneven lighting. So if you hit display grid here, it'll show the grid with this spacing on your printer screen, so you can make sure that the lighting looks even, or whatever you wanted to check. It's probably mostly for checking intensity of the backlight. Make sure you don't have any dead zones. But I'm just going to hit display blank. These controls right here are to manually move up and down the build platform. And keep in mind that the way Arduino works, it will not let you move in a negative direction until you home that axis. So if we don't hit this home button, we can't use the negative buttons. It's not going to move down. So the only way to move the platform down at this point is to manually use that little screw on top of the lead screw, and we can drop the platform down into the vat where it should be if it's really far away. And obviously if we hit the home button, it will move in the negative direction, but it's going to go all the way to the homing switch. And sometimes you don't want that. So if you got to move in the negative direction before you home it, you'll have to do it manually. So I usually pour the resin into the vat first, once I have made sure that the screen is on and working. And then after the resin's in the vat, I will hit the home button and let it home the platform. And you do have to loosen the screws on the sides of the platform, so remember to loosen them. That way when it gets to the bottom, it can slide up as it goes down and hits the homing switch. So that's pretty much it on the homing switch. This speed up here, you can change this to be faster or slower. 10 is pretty slow, but you don't want to get too crazy. And then right here in the print settings, this is what we're going to be looking at. These are exposure times, and this is where we're actually going to set the exposure for our layers. So remember I said when we exported the slice that it was pictures only or images only. This is where we're going to determine our exposure times, and that way we can change it whenever we do the actual print, so it's not baked into the file. So I use 7.3 seconds, which is 7,300 milliseconds, 23 seconds for my bottom layers. I had 10 bottom layers. And the layer thickness was 50 microns, which is pretty standard. Now the z-axis speeds here, these are the speeds for the z-axis to go up and down when it's peeling your part off the film during or in between layers. But we're actually not going to use these. So if you want to use these values here or set them, you can, but I found a more optimum method is to use a custom G-code script, which I've loaded over here. And keep in mind, this was the same setup that we had in the slice settings. Remember, I showed you could open them up and edit them. This is the same thing, basically, but in a different place. And we need to use this one because we're not using an actual file that has these settings saved in it. All we're using is the images. So up here, this is the job start. And then this part right here where it says slice repeated, this block of code in this box, this is the one I modified. And I also did modify the job end down here to include the M107, which turns the light off. And that's just to make sure that the light does not stay on when the print finishes, just in case something goes wrong. But I'm not going to tell you exactly how this works because it would take too long, but I will include this little block of code in the Thingiverse page. So check on the Thingiverse page where the group for the printer is located, and that's where you're going to find this file. And you can just copy it and paste it into here, and then you would go down here and hit save, and it should stay within the program, as long as you're using it, so you'll never have to change it again. But essentially, this makes the platform move in a non-linear fashion, because normally the platform would move at a constant speed. So in other words, it would move at 50 millimeters a second right here on the lift speed for however many millimeters. So if we were moving 5 millimeters up, it would move at this speed for all 5. And the G-code script says move really slow at the bottom when it's first peeling the part off, and then as it goes up through the resin to the top, it speeds up because the part has already peeled off the vat, and that's the most critical part, is that it goes slowly while the part peels off. Once it's off, we want to move as fast as possible. And for the math people out there who are saying, why did you guys use this custom G-code script? You don't have to use this, but the simple answer is time. I use this G-code script in here to cut out time in the print, because these prints take a long time, and ideally we want to make the print as fast as possible so that it doesn't take a ridiculous amount of time. So if you were to use this value over here of 30, and we're just going to ignore this one for simplicity's sake, and we're going to leave this at 100. So if we were to use these settings here, and it went up at 30 millimeters a second, so in other words, the platform is rising up at 30 millimeters per minute for a distance of 5 millimeters, and when it reaches the top and the part's been peeled off the film, it returns at 100 millimeters per minute. The difference in time between that right there and this value right here, plus 400 more milliseconds that are also in here. Let me show you guys what that difference was for the math people out there. That difference comes out to 1.15 hours, or right here, 69 minutes. So we saved a total of 1 hour and 9 minutes off of the print time, because remember, for every layer, the platform has to move up and down, and we have 978 layers. So it seems like you're only saving a couple seconds, but when you take those seconds and you multiply them by 978 and you figure out the difference, we saved 1 hour. So our print will be 1 hour shorter thanks to this script in here. That's why we use it. Okay, so at this point, everything is ready to go. You should have your G-code script loaded. Everything's connected. Your resin's in the vat. You've remembered to home the platform. Make sure and tighten up the knobs on the side of the platform so it can't move. So at this point, remember to just tighten the nuts on the vat as well. And you just want to run them down until they barely touch so that the vat itself cannot be picked up off the screen as it peels the parts off. We're connected. So all we're going to have to do now is hit start. And the printer will start printing. You can notice here that it's compiling the G-code, and once it's done, it's going to start the print process. And you can see it tells you the slice number here, slice 0. Tells you how many seconds it's going to take, because this is a starting slice, so it's going to take longer than 7.3 seconds. And it's going to show you the slice that's being currently printed right here. If you guys hit this full screen mode, it just full screens, and you can see it's going to say moving platform during the platform movement, and then if we wait here for a second, the next slice will pop up. So as soon as the platform finishes moving, it's going to pop up the next slice, and it just shows it full screen. And this bar down here, you're going to get a green bar down here showing the print progress. And it'll show you the layer right here. This is the layer count that it's currently on. And the only thing, you can just hit escape to close this, the only thing that is not accurate is the total time. Notice here it says total time is 7 hours and 45 minutes. That is incorrect because this time estimation is not taking into account our gcode script. It is using these values here that are typed in. So if you adjust these values to get close to the result you achieve when you print with this gcode, you can get the estimate to be accurate, or at least close to accurate. But you'll have to do at least 1 or 2 prints and time them to know exactly how long it took. So I think mine took roughly 4.5 hours to print the grunts. So if you print them at the same scale, you should have roughly the same result and speed. Granted, you also have 7.3 second layers. You may have to adjust this up or down a little bit for the resin you're using, but on most of the hard resins, somewhere between 73 and 7600 milliseconds is perfect, so keep that in mind. Okay everyone, so the print just finished. Took roughly 4.5 hours using the photocentric print controller with roughly 7.3 second layers. So basically all we have to do now is open the case and tilt the platform so that the extra resin can drip off the platform out of the models, and then from there we'll go to our cleaning station where we'll get the prints off the platform and rinse them. So we're just going to reach in here, try not to block your view. We're just going to loosen these side nuts. And we're just going to gently tip this up like this until the resin starts to drip off. And you want to keep an eye on these models that are sticking out over the edge here, because a lot of times if you want to leave it up in the air for maybe 5-10 minutes first so that it can kind of drip off. Otherwise, if you try and go in here right away and tilt it, you'll have a lot of resin dripping down on the front of the tray here, or maybe on the platform. So pretty hard to clean up the resin, so try not and let it drip anywhere besides back into the vat. I don't know if the focus will be perfect on these, but from what I can tell here, they pretty much all look flawless. We did lose a grunt in the back there. There was supposed to be 6 total, so one of them broke off the supports. So it may have had something to do with the fact that I anti-aliased the slices. Oops, see, we got a drip here on the front. I've never actually used Photocentric Studio itself to do the print, and it offers the option to anti-alias, but that could have made the tip of the supports a little bit smaller, since anti-aliasing generally smooths the pixels out, and sometimes that means a smaller footprint. So could have been a problem there, but sometimes you gotta let it back down a little bit like this and let some of the other resin drip off the prints. But generally speaking, if you leave it in there, like I said, for about 10 minutes, give it a chance for the models to kind of drip off first, it's not too messy. So what I'm going to do now is we're just going to leave this at the max angle we can leave it without these models getting broken when I close the door. And we're actually just going to close the door up, so this position here should work without the models hitting the door. And there we're just going to leave it for about probably 10-15 minutes. So from there we'll get our gloves on and everything and go to the washing station. So we'll let this drip off here. Okay, so here we are on the rinsing table. I'm going to try and make this as quick as possible because I don't want all this extra resin on here to start curing from the lights, because normally we don't have this much light. For the camera setup, we need more light than we would normally have in the room, so we're basically going to use this putty knife here. It's just a regular cheap putty knife. You can see it's pretty thin. And we've taken the edge here and sharpened it with a grinder so that it gets under the prints a little better. So we're just going to start scraping them off. And you just kind of work the knife back and forth a little bit, left to right. It seems to help get under the prints, and you don't want to try and get under them real fast or you'll end up breaking them. It's more important to just kind of slowly wiggle it around until it gets underneath the print. I'm going to dump this off so we don't break anything. These are the pieces of the grunt we lost. So, RIP grunt. And sometimes these supports are hooked to something delicate, like in some cases they're hooked to the fingers of these grunts, so you don't want to crank on them too much or you might end up breaking off a finger. Because right now you can see the resin is in a cured state, but it's not a finished cure, so the resin's still flexible and soft. Almost like, kind of like licorice maybe. Try and get this to fall out of here. So there's 3 of my plasma rifles. See if we can get this top grunt off without breaking anything too important. Got everything here but these last 3 rifles. And if you notice the back of the rifles, the little fins are missing. But it's just because of the scale of the rifle, they're too small. I knew they were not going to survive the print, but I just left them on there anyway. So we're going to carefully make sure here and just scrape off any bits of resin, because we don't want chunks of resin on here that are cured. And this is especially true if you have to stop a print and restart it. Make sure and get those chunks off. And then from here, we're just going to actually take the print platform here. You can see it's still got resin on it. We're going to throw it back in the printer at a 90-degree angle and let some more resin drip off. Okay, so normally you would leave these parts separated out here so they could drip off a little bit more and get some of the extra resin off, but like I said earlier, I'm under these lights for the recording, so I'm going to pop them straight into the rinse bath so that I don't want to cure the extra resin on the outside. So this rinse bath is basically just a snapware container with a printable mesh here, like a little elevator. And all we're going to do is just set them in here carefully, try not to break anything. And we're just going to give them a couple rides up and down in the photocentric resin cleaner. This is not alcohol. You can use alcohol. If I can fit all these grunts in here. So we're just going to slowly lower it down here into the stuff, and you'll see all the air bubbles. That's the air coming out of the inside of the grunt, so you got to wait a second for these guys to sink down where they should be. We don't want them floating because they won't rinse properly. And we also want the rinsing solution to go inside of them, so that way we get the inside rinsed as well as the outside. We don't want a bunch of resin sitting inside of the grunts. There we go. Okay, so this, like I was saying, this is just a snapware container here. I think it's 4.5 quarts or cups. maybe 4.5. This is not quarts, obviously, so I think it's a 4.5 cup or 5 cup. It's a specific size that looks like this. And you can see this photocentric resin cleaner is actually really strong stuff. This is the lid of the snapware container. Let's see if we can get it over here better in the view. And you can see it's actually starting to mess up the seal. The seals on these snapware containers are some kind of silicone rubber. But this stuff is so strong, if you look here, you can see it's kind of mashed up at an angle. It's actually starting to soften and destroy the silicone. So, pretty strong stuff, but the nice thing is it's not flammable. So if this was full of rubbing alcohol, you'd have a fire hazard, and you have to be careful around that kind of stuff. But in this case, this is not flammable, so the only thing you gotta do is make sure and wear gloves. Don't get the stuff on your skin. And we're just gonna let it soak here for a minute. So it's been in there for like maybe 1 or 2 minutes. Now we're gonna start going up and down gently to just kind of help rinse the outside off. We don't want extra resin on the outside of the models because we're going to lose a little definition if there's extra resin on the outside, and it'll also be a little tacky when we go to cure it in the final post-cure. So we want to get as much extra resin off as we can. That way when we post-cure it, the outside is dry to the touch, and we'll get as much detail as possible. And I don't know if you can tell, but my rinsing bath is fairly dirty. I've rinsed a lot of prints in this bath, and you can reuse this stuff over and over. So I've probably rinsed 30 to 40 batches of prints through this bath at least. Some were small, some were large, but it's getting pretty dirty, so at some point I will have to change it out. But I'm going to let it soak one more time at the bottom here, and then we'll switch out the plasma rifles here before they start curing in this light. Overall, the plasma rifles look pretty good. For their scale, they came out pretty well. When we rinse them, they'll look even better. Just like I said, we lost little fins here on the side, but they were just too tiny for them to survive. So, fortunately, we lost that one grunt, but that one firing grunt we lost. Like I said, it looks like to me the tips of these supports are a little smaller. I normally slice the models and print them in Creation Workshop, but I wanted to use the photocentric because it's a lot more simple and has less glitches as far as just program features and stuff like that when it comes to printing. And it also uses less memory, so it's more like a background task. It doesn't use so much memory. But I've noticed here that the tips of these supports do look a little smaller, even though I didn't change the actual file. The files I used for printing this last time, the tips of the supports were slightly larger, so if I leave the anti-aliasing option on, I may have to bump up the tip sizes on the supports and then they'll quit breaking. But other than that one grunt we lost, everything looked pretty good. So by now, this has been a couple minutes. These guys in the bath should be good to go. So I'm going to bring another container over here for you guys to see. Okay, so this container here that I brought over is just a Sterilite container. I don't remember the exact size, but basically what I have in here is pretty hot water. Not hot enough to burn you, but fairly hot. And we're just going to drop these models that we took out of the rinse bath here. We're going to drop them straight into the hot water, and I put a little bit of dish soap in the water just to help the resin not stick to the container, because there's still going to be leftover resin on the outside of these prints, even though we've rinsed them and all this stuff. You can see here we're letting some of the fluid drip out of the inside of this grunt. I don't know if you could see that, but I'm trying to get some of the photocentric resin cleaner to come out of the inside. And then we're just going to drop them into the water. If we were to take these grunts as they are and go straight to the post-curing, they would be a little bit messy, a little bit tacky on the outside. So that's the reason I basically double rinse them. Once in the resin cleaner, which gets, 90% of it off, and the other 10%, it doesn't all come off ever, but most of it comes off when you put it into hot water. The hot water helps the resin flow more easily, which makes it rinse off. And like I was saying, the soap just keeps it from sticking to the container, because the resin is kind of like, I don't know how to explain, it's kind of like the consistency of honey, but a little thinner, and it's hard to keep it from sticking to stuff. So, see if I can get all this stuff out of the inside of the grunts. And we're not going to rinse the plasma rifles as long, because they don't have any cavities, they're smaller, they're not as detailed really as the grunts as far as the overall model, so I'm not going to worry so much about rinsing them as long. But now we're going to just drop the rifles in here. Nothing fancy. We just want to get the extra resin off the outside, and that's it. And the grunts here are trying to float in the water. You can tell they're determined not to go down, so I'm going to rinse my fingers real quick in the resin cleaner, get some of the resin off. And then I'm just going to go in here and push these guys down so that the water goes inside. I want the water to go inside the bodies, because only then can we get them to rinse out, or at least semi-rinse. And you do want to be careful with them at this stage, because remember I said they're about as strong as licorice, so if you grab something too small and rip on it, or you rip it out of the water too fast, you'll tear an arm off or something. And when you put them in hot water like this, they become a little softer. So you got to be gentle with them. Don't grab anything hard. You want to just keep almost like a loose hold. You just want to hold them in your fingers, but not actually squeeze them. So we're just going to give these rifles a few passes up and down to make sure they're clean. And that should be good. Just carefully drop them in the water as well. And you want to try and avoid losing pieces of your models inside this bath, because they will start floating around. So if a piece falls off onto this little elevator thing here, try and pick it up and get it out, like this little support here in the corner. Try and get the pieces out of there, because they're going to keep floating around inside. And then at this point, these guys in the water will be good in a second here, but I'm going to go ahead and put this back on here, because my rule of thumb is if it's closed, it can't be knocked over and spilled. So since this stuff is very strong and we don't want it leaking anywhere, I'm going to go ahead and clip this on, and that way we can't accidentally knock this over and make a bigger mess. Okay, so at this point we're good to go. All the print and the water are good. This is my post-curing station. I don't use sunlight because it's not that reliable. Sometimes it's light, sometimes it's overcast. So essentially what this is another Sterilite container like this painted white so that the light bounces around inside of it and doesn't go out too much. So it basically acts as a reflector. And this is basically just a voltage controller followed by a current controller, because I had to boost up the voltage. So one of these boosts the voltage from 12 volts to 32, and the other one just controls the amperage. I didn't have a module that would boost and control the amps at the same time, so I used two. And basically this is just a heat sink here with a fan on it, and on the bottom of this heat sink, I'll show you in a second, is just one of the 20-watt chips that we're using in the printer. So just buy a couple extra chips, like maybe 2 extra chips, the LED chip. And you can see in here, hopefully this is not off screen. You could just barely see it up here at the top. There's no hole. I just basically left a spot where the paint was not covering the container, so it's transparent. And this bracket is what holds the heatsink in place. So this light just shines through the top of the container into here. And like I said, it's just a 20-watt chip, so it cures all of the parts. So what we're going to do now is we are going to just fish around and find these things. And we are going to give them a little swish in the water before we take them out, just to get off any droplets of resin, because sometimes there's little drops of resin. And you might see some appear in the water here. If you watch in the water, you might see some little red drops that start appearing. Those are globs of resin that either came out from the inside of the model or they were on the outside. One of the rifles. I was covering up one of the air holes so it wouldn't drain. And this is more than I normally print. I normally probably would have printed maybe 4 grunts and a rifle or 2. But the printer is capable of printing large batches. That's the whole idea of having the large platform and the large screen. So that you can not only print large objects, but you can print a lot of small objects all in one shot, which saves time. So this is a fairly large batch of prints. At least for miniatures for me. Alright, we didn't miss anything, so this hot water will kind of help clean off your gloves. So if you have any resin on there, just kind of rub your fingers inside here and you'll get most of the resin off. And now we're just going to basically close up this container so we don't spill it. Get it out of the way. And then we're just going to push these guys down so they quit bobbing. We don't want them floating. We want water to go inside of them, because the resin itself cures much slower when it's in the presence of oxygen. So that's the purpose of submerging the parts in water, is it isolates the resin from oxygen, which means that it will cure at a much faster ratio and it will cure much more completely. You'll never get 100% cure from a part that's in the air. It'll always be tacky on the outside. So you want to put them in water, and the hot water basically just accelerates the curing process. So now that they're all chilling down there in the water, as soon as I get my gloves cleaned off here, we're just going to flip the lid back over here. And this little dongle here just goes straight to a 12-volt power supply. So we're just going to plug it in. This whole thing's going to light up blue. And we'll leave them in there for about 30 to 40 minutes and they'll be good to go. Okay, so here's all the models after they've been taken out of the post-curing station. I did have a little bit of resin inside of one of them, which is why you see these Q-tips here with resin on the tips, and you see a little resin on here. I had to blot some of the resin out of them, and then the resin gets on the outside of the model, so I popped them back in for another 5 minutes just to make sure they weren't wet with resin on the outside. But there was a little bit of resin trapped. You can see the drain hole here. There was a little resin trapped inside of this guy. but it's going to happen no matter how well you try and rinse them out. Sometimes the resin just doesn't want to come out of there, so they're pretty much done here. You can see the plasma rifles came out really good. I haven't really decided which one's the best looking, but this one looks pretty good here. So you can see all the supports here are going to be clipped off. But you can see the little notches survived inside the rifle there if we hold it at the right angle here. Right here. You can see the little notches inside the front of the rifle survived, and the trigger mechanism here also survived because we put a little support in here to make sure this wasn't an island. So it was. So we'll put the plasma rifle back here out of the way. These are obviously the sleeping grunts. We printed them this direction because that was the best way to orient them. And you can kind of tell we didn't go over this in the software because of time, but we put supports between the arms here and the torso because the print was progressing this way. So if you look inside there, you can hopefully see the little supports between his arms and the body. And all the grunts look really good except for one of them here. Let me show you the one here that had a problem. This is one of the two firing grunts that survived, but for some reason this little area right here underneath his pelvis, the support's broke, and I'm not sure why, because these supports are really short. So generally it's the longer supports like this that go further that are the ones that end up breaking. So I don't know why the supports right here under his pelvis broke, but you can see the result was the bottom of his pelvis didn't print where it was supposed to, and then there's a gap in his leg over here, so his foot is not connected to his actual leg, and the bottom half of his leg is missing. So we can fix this kind of quick and dirty as long as we leave this foot attached to the supports here. We could go in here and fill in the gap where his leg is with some, all-purpose putty or whatever you guys would use for your models. Basically fill it in and sand it with a file and fix him. But that's kind of a good example of how crucial the supports are in models. Is you can have a perfect printer, $5,000 SLA printer. If your supports are not strong enough, then you're going to have print failures. So I know for a fact that there's nothing wrong with the physical parts of this printer, but if I had made these supports a little bit larger, then it wouldn't have broken. And just one note, like I said earlier, I've never used the photocentric print controller before to do an actual print. So I think that's why some of these supports are breaking. I printed all three of these grunt models. I printed the firing grunt, the sleeping, and I have another pose that I showed you guys, which is the standing grunt. And I printed all of them. I think I printed 4 or 5 of them on the Creation Workshop program, and there was no flaws. Every single grunt survived. All the supports were good. So that's why I used that model, is because I already had it prepped and done, and it wouldn't take me hours to get them all ready. But like I said, the supports are a little weaker on the photocentric anti-alias version, so just keep that in mind. You might want to scale up my settings that you saw just a wee bit. But this guy is a good example of one where the supports didn't break. You can see the legs and the torso. They're pretty much perfect as they're ever going to get. And once we let this dry out for a day or two, you can go fill these in with, whatever putty you use, drywall mud, maybe a little epoxy, super glue, whatever you want to use. You could even use resin, but it gets a little messy with the resin. And to get these supports off, all we're going to do is clip them off with a pair of scissors. So my method for getting off the supports is I use a pair of small scissors like this. Some people call them surgical scissors. You could probably pick them up at the drugstore. I buy them online. And then basically you're going to clip the tip of the support. So let's say we want to remove this support here. We would just clip that support almost to the point where it touches the model. So if you were looking at it from that side, I would probably clip it right about here. I don't know how well you guys can see that, but you want a little gap between the model and the scissors, because if you put the scissors all the way down against the model, when you go to clip the support off, it's going to basically break off a piece of the resin and leave a pocket in the model. And it's better to have a little piece of resin sticking off the model that you can file down than to have a hole you have to go back and fill. So I'm just going to clip a couple of these so you guys can see. They go flying everywhere, so you might want to wear safety glasses when you guys are doing this. I know that sounds funny, but they will hit you in the face. And these guys are all kind of connected together on the bottom, so I'm going to have to clip them, a couple of them, before they start coming loose. And you can see this is what you want. You want these little leftover nubs sticking up off the rifle or the model or whatever it is you're clipping. And you can just come back with a small file or sandpaper and take these down. It takes a matter of seconds. So that's just basically how you clip out the supports really quick. I do recommend clipping the supports within, I'd say, probably 4 hours of letting these dry. So once you've post-cured all your models and they're dry, go ahead and get your scissors and clip off the supports if you have the time. Because if you try and clip them the next day, the resin keeps drying out over the space of about 3 days. And as it gets more and more dry, you know, further down through the model where you can't really see it, the plastic gets more brittle. So when you clip off the supports the next day, they're really brittle and the pieces fly everywhere, and it's a little more difficult to clip them without messing up the model. So I would highly recommend just do them the same day. I just want to show you guys really quick here how I clean the platform, because if you clean it wrong it can become quite a little nightmare because it's a complex shape. So this is a larger Sterilite container. Painted this one black, just like the rinse station we saw earlier. And that's to keep light from going in here and curing resin, because what happens is we have the same photocentric resin cleaner in the bottom here. We have the same photocentric resin cleaner in the bottom. It's only about maybe a 1/4 inch. Doesn't take too much. But if we allow the light to come in here when this is sitting in your room or your shop or your business or wherever, that light's going to cure the resin that's suspended in the cleaner. And when that happens, it gets really messy really fast, and the cleaner's not usable. So if you keep the light from entering the container, that's going to basically make it reusable much longer, because the resin that's suspended in there doesn't start curing. So all we're going to do is we're just going to open the lid here. We're going to take the platform. So imagine this is the platform. And we're just going to basically drop it straight down into the resin with the handle part up. Or straight down to the cleaner, sorry. And we're going to leave it there for about 10 minutes. After 10 minutes, we're going to switch it back and forth maybe 15 times, 20 times, until we get the resin to rinse off of the aluminum. And then I'm going to pick it up, take it out, and I'm going to set it like this. So see how this is diagonal? Imagine this is your platform. So I'm going to take it from right here. I'm going to turn it 45 degrees, and I'm going to set it right here into the top. And what it's going to do is these two edges here will support it, and it's going to all the cleaner is going to drip off. All the cleaner is going to run down to this corner, and it's going to drip off into the bottom. And after about 5 minutes, then I'm going to use some rubbing alcohol and a paper towel to clean it off. And from there, I put it back on the printer, and you're good to go. I wanted to show you guys the vat draining process, but it just didn't work out. So I'm going to just give you a quick how-to. This is the base for the resin bottle. So you're going to set the resin bottle inside of the base like that, and that keeps it from tipping over. And then this is basically a funnel, but it's customized to hold the vat. So what you're going to do is you're going to put a little piece of strainer material down here. I use paint strainer material. I cut a piece maybe 3 inches by 3 inches, put it against the end here, and kind of press it inside with your finger. And then this is going to go into the top of your resin bottle. So this surface here is designed to fit exactly inside of the resin bottle. So it's going to go inside like that. You're going to end up with the strainer media right here inside. So no bits of resin can go back into your bottle, because you don't want that. And then essentially all you're going to do is you're going to have your vat like this full of resin. You're going to just put this pouring corner over that funnel, You're going to slowly tip it until it pours out, and then when you get to the vertical position, you're going to set it like this into the funnel. And you can tip it like this to help get more of the resin out, but the point is, it's hard to hold this to show you, but it's going to stay in here automatically. You don't have to hold on to it. So the way it's designed, it'll sit here and drip out on its own. And the one thing I do to speed up the dripping process is I take the Bondo spreader that you guys saw earlier. It was the cream looking spatula thing. I use that to wipe the inside of this, and it moves all the resin down to the bottom corner real quick, so you don't have to wait 20 minutes for it to get down there. And the Bondo spreader is a soft plastic, so it doesn't scratch up the FEP film. So basically I'm going to put this inside of the funnel like I showed you. Then I'm going to take that spatula and go in here like this and basically just wipe it down to this edge and then make sure that it runs down, and that's it. It takes all of 5 minutes for this to drip out, and then you can go wipe it off and you're good to go. So